So with 2.4 and dividing polynomials, what we'll talk about today mainly is going to be long division and synthetic division. Okay, we'll hit remainder theorem and factor theorem tomorrow, but the dividing part for everything for today. So what you were accustomed to whenever you were in your Algebra 2 class or whatever class you came from the previous year, we dealt with dividing polynomials. Okay, the first thing we talked about was long division, and then we dealt with synthetic. Okay, hopefully what you understood was that synthetic was a heck of a lot easier. Okay, because normally it is. Okay, long division is one of those that you always kind of have in your back pocket that you can always do. Okay, it's kind of like the quadratic formula of quadratics. Okay, it's always relevant. You can always use it. Same way with long division and dividing polynomials. Okay, because synthetic's not always going to work every single time. Okay, there are only certain cases that it will work. Okay, it will work whenever, synthetic will work whenever you have a power that is 1 and only 1. Okay, if you have a power that is squared or cubed and you're dividing by that, you're not going to be able to use synthetic. You treat everything with long division just like you did, and if you had me in class last year, basically we showed you like an old second, third grade problem where you actually had to use long division. Okay, and we went from there. Everything still is the same thing. You treat it just like you did in second and third grade when you were dividing. Okay, especially if it didn't happen where you have a remainder, and sometimes you may have a remainder and sometimes you may not. So if we divide x squared plus 10x plus 21 by x plus 3. So I'm going to set everything the same way. I'm going to set it up the same way I did before. And I'm going to have like the box. And the biggest thing that I have to make sure is everything has its place. Whatever the highest power is, that's what I want to start with. And then I have to make sure that it goes down by 1 from there on out. If I don't have a value for, say, an x or an x squared, and I started at an x to the third or something else, I have to have some sort of placeholder. Okay, so if I have some sort of placeholder, whenever you were younger and you had, 2054 and you were supposed to divide it by 27, that 0 was just a placeholder for the hundreds place. Just because you didn't have 100 there didn't mean that 2054 turned into 254. Okay, it had to have a placeholder. Now, in this one, it really doesn't matter, because you have x squared, you have a positive 10x, and you have a positive 21. I'm dividing it by x plus 3 on the outside. Now, what you were taught and what I do may be two different things, and that's okay. I'm just going to show you how I do it. Okay? This one here, you can actually do synthetically. Okay, and we'll go through that in a second. Okay, because your x value or whatever you're dividing by is to the first power. It's x to the first power, so we can actually do this synthetically as well. Now, the way that I show long division is I just look at all of my lead terms. So I'm going to look at x squared, and I'm going to take x squared, and I'm going to divide it by whatever my lead value is right here. I really don't care so much about everything else as I care about my lead values. I care about the lead value that's underneath the box, and I care about the lead value that's just outside of the box. So what I'm going to do is I'm going to take x squared and I'm going to divide it by x. So what's x squared divided by x? Just x. Okay? That x is going to go above the x on top of the box. Now, from there, whatever is outside, okay, this whole part is going to get multiplied then by the x that I have. Whatever I get there, all I'm going to do is I'm going to slide that value right here. So what's x times x plus 3? plus 3x. So, just like I did with division, okay, whenever I was in second, third grade, whenever you started doing that, is I subtracted. So once I multiplied, now I just subtract or change the signs, however you want to look at it. So then the x squareds and the x squareds cancel. That's what I want to happen. I want basically nothing to be right here. Okay, if I end up with a value, then I did something wrong. So x squared minus x is just 0 or nothing. And then I'm going to go 10x minus 3x, and I'm going to end up with 7x. Drop down whatever the next value is, so plus 21. Now, I have a new lead value. I'm going to take 7. Whoop. I'm going to take 7x. I'm going to divide it by x again. So in doing that, I'm going to take 7x divided by x. What's 7x divided by x? Just 7. That 7 is going to go, it's a constant, so it's going to go above my constant that I have on top of my house or on top of the box or whatever you want to call it. Now, again, I'm going to take that 7 and I'm going to multiply it by x plus 3 again. And I'm going to end up with 7x plus 21. I'm going to subtract or change the sign, whatever you want to call it, of everything on the bottom side. What happens to everything? It cancels out, right? So I end up with 0. Okay? If I have a remainder, okay, this is my remainder right here. If I have a remainder, then that value is going to go up above the x plus 3. Since I don't have a remainder, then x squared plus 10x plus 21 divided by x plus 3 is just x plus 7. Okay, so my final answer here is just x plus 7. I don't have a remainder, so I don't have to worry about it. Now, the flip side of this one is you wouldn't have to necessarily do long division here. Okay, in this case, you could actually do synthetic and basically flip your box upside down and have, if I have x squared plus 10x plus 21, all I do with synthetic is just basically take the coefficient that I have in front of each value. So I'm going to have a 1, I'm going to have a positive 10, and I'm going to have a positive 21. I don't bring the x squared to the x or anything like that. Now, the one thing that I have to make sure, if I'm dividing by x plus 3, I need to take x plus 3 and set it equal to 0. So what is my actual x value? Negative 3. So that negative 3 is going to go out in front. So if you remember from your previous time, all I'm going to do is I'm going to drop my first term. So in doing that, I'm going to have 1. Then multiply those two values. So negative 3 times 1 is negative 3. Just basically add straight down. So 10 minus 3, 7. Now take my new values. So my negative 3 and my 7, multiply those two together. Get negative 21. And then add straight down, and I'm going to get 0. Now, from here, whatever the last term is, that's my remainder. Then I have my constant, and then I have my x value. I just work my way up power-wise from the right to the left. So, I didn't have a remainder. My constant was 7. My x value was my x value was 1. So then just like it was before, x plus 7. So on 2, okay, I'm still going to go through and do long division. Okay, because long division is, again, it's one of those that I can always do, and it's always kind of in my back pocket as far as a way to solve any of these. So the first thing I have to do is I have to put everything in order from the highest to the lowest power and making sure I'm not missing anything. So I have 6x to the third. I have minus x squared. I have minus 5x. And then plus 4. So I have the 3x minus 2 on the outside. Now, we could do synthetic here, but I'm going to show you kind of one thing you've got to pay attention to here in a minute. Okay, because if we do synthetic, you get the same answer, but you get a different answer at the same time. Okay, and that'll make a little bit more sense here in a second. So again, always look at the first term and the first term. So I'm going to take 6x to the third, and I'm going to divide by 3x. So whenever I do, what am I left with? 2x squared. So that 2x squared is going to go above my x squared, so 2x squared. Now, multiply it with 3x minus 2. Whatever I get there is going to go right here. So 2x squared plus, 2x squared times 3x minus 2 is going to give me 6x to the third minus 4x squared. Change my signs. So I'm going to change this to a minus and this to a plus. My 6x to the thirds go away. That's what I want to happen. So then I have negative 1 plus 4. So I'm going to have 3x squared drop my next term, so drop the minus 5x. Now do the same thing again. Now I have a new lead. So now I'm going to take 3x squared and divide it by 3x. So what am I left with? Just x. So that x goes above, so it's a plus x. Now multiply it by the 3x minus 2 again. Whatever I get is going to go right here. So x times 3x minus 2 is going to give me 3x squared minus 2x. Change my signs. 3x squareds cancel, giving me a negative now drop my 4. So now I have a new lead. Okay, so I have a negative 3x. So I'm going to take that negative 3x and I'm going to divide it by the 3x that's out in front. So what do I have left? Negative 1. So it's going to be a minus 1. Take it and multiply it with the 3x minus 2. So I have negative 3x plus 2 change my signs, so I'm left with a remainder of 2. So if I have a remainder of 2, I'm just going to put it 2 over whatever's on the outside. So over the 3x plus 2. And there is... Nope, it is minus 2, yes. My fault. Thank you. Okay, so we can do this synthetically. So if we do this synthetically, I'm going to still do everything the same way that I did before. I'm going to have a 6. I'm going to have a negative 1. I'm going to have a negative 5. And I'm going to have a positive 4. Now, in this case, if it's 3x minus 2, I've got to figure out what's going to go kind of in my little area right here. What number is going to actually go there? 2/3. Okay, so if you don't like dealing with fractions in this case, I would stick to long division. If you're okay with dealing with fractions, and to be perfectly honest with you, they're not going to be nasty fractions in this case. So I know going in I have 2x squared plus x minus 1, and then kind of go from there. Remember, if we use synthetic, we're just going to do what with the first term? Drop it like it's hot. Okay, so I have 6. I don't have a 6 over on the other side. Okay, that's okay. We'll get there and you'll kind of see. So then 2/3 times 6 is what? 4. So I have a positive 4. So negative 1 plus 4, positive 3. Now 2/3 times 3 is going to be a positive 2. Straight down. So then I'm going to get negative 3. 2/3 times negative 3. Negative 2. Oh, let's change colors. Straight down is going to give me a positive 2. Remember, here's my remainder, there's my constant, there's my x, and there is my x squared. So if I do this synthetically, I end up getting 6x squared plus 3x minus 3 plus 2 over the 3x minus 2. What's the problem, though? Are they the same? Kind of. Did we do both of them right? Let's put it that way. Yeah, how did we get 2 answers then? Huh? One's more simplified, right? Okay. What do we need to do with the one over on the left? We need to factor out that 3, right? Okay, so what we would have to do here, if we do it synthetically, we would have to basically factor out a 3. Now, is it the same? Okay. We factored out that 3, right? Okay. So understand that if you do it synthetically, that's all well and good, but if you can take out another factor, we need to do that. Okay, that's why sometimes doing long division, again, it's in the name, it may be a little bit longer, but it's going to get it simplified immediately. Okay, or it should. The biggest thing with long division is you've got to make sure you take your time. Okay, don't get in too big of a hurry. That's why whenever I do it, that's why I kind of do almost like simplified, smaller problems, and then just go from there. Instead of trying to look at it as one big thing, to kind of take it and break everything down. Now, I don't think I'm going to have enough time to get through the third one, but really just to make sure you can set it up. Okay? I don't have a choice on this one. I have to use long division. Now, the problem here is, what am I missing? I'm missing an x squared. So I have to make sure if I have 5x to the third, if I don't have anything right there, it goes from x to the third to an x, I still need to make sure that I have plus 0x squared. Okay, plus 3x minus 5, and then I can actually divide by 3x squared minus 2x. Okay, the big key here is making sure that you have that placeholder. Okay, you're going to need that. If you make any sort of mistake, the biggest mistake that's going to get made is going to be not having a placeholder. Okay. Honestly, using synthetic is pretty simple. It's just making sure that you go with the opposite. So like you have that, if it's x plus 3, then you're going to need to synthetically divide by a negative 3. Okay.